Okay, so an interesting question given to you is the set S which is union of these many intervals. And T is a set which is a discrete set. Only four elements are there in the set. Now they are asking which of the following statements are true. Number one is saying that there are infinitely many to T. Is it true? Let's draw it. Okay, function, how do you draw? Like S is, I will draw on the x-axis, and on the y-axis I will draw T. Okay, let's see. So 0 comma 1, so everything here, right, is in your S. Then 1 is not there because it's an open interval, right? So from 1 to 2 everything is there, then from 3 to 4 everything is there. Okay, so this is your set S, the intervals. And what is your set T? Okay, only four elements: 0, 1, 2 and 3. Okay, so these are only elements in T. Okay, now let's answer that. How many elements you have in S? Infinitely many, right? So there are infinitely many elements here in this, in every interval there, you know that infinitely many elements. Now to each element it's your wish, right? Either you go give 0, 1, 2 or 3 to each one. Okay, but there are infinitely many of them, right? So yes, there can be infinitely many functions, right? So option A is true. Now let's go to option B. There are infinitely many strictly increasing. So now that's going too far, right? Strictly increasing means what? Like if to one element you have given 0, then to the next element you should give a 1. Then to the third you should give a 2, because those are the only elements you have, right? To the next you should give a 3, isn't it? But there are infinitely many elements. How is that possible? Not even one I can have, right? They're talking about infinitely many. So of course this is not true. Now go to option C. The number of continuous function from S to T is at most 120. Okay, let's see how many continuous function we can have. Okay, so if I want a continuous function, so 0 to 1, for this whole thing I have to define either 0 or 1 or 2 or 3, right? I have four options. So for this interval I have four options to define. Now for 1 to 2 also I have four options. Okay, because either I say 1. Okay, let's say, let's draw it. Okay, let's say from 0 to 1 I have function value to be 1, like this. Okay, for 1 to 2 I have, let's say, function value to be 2, let's say. Okay, so I'm going to have 2. Now don't say that it is not continuous at 1. Okay, because 1 is anyways not there here. Okay, so I don't bother about the continuity at 1 because it's not there. Okay, otherwise it is continuous. You see, this is here 0, 1 it is continuous, 1, 2 it is continuous. Again for 3 to 4 interval also you have again four options. You can give those 0, 1, 2 or 3, because they have to have a constant function. That's the point. Okay, otherwise it won't be continuous, right? If you, like, half of it you give 3 and half of it you give 2, okay, then of course it is not continuous here. Okay, so you have to give just one value to all of them. Okay, so here also you have all the four options. So how many are there? 4 times 4 times 4. Okay, how much is that? 16 4 is 64. So you can have 64 continuous function, but they're saying what? At most, okay, at most 120. Okay, so yeah, I mean, not very accurate, but yeah, it is lesser than 120, so I will say yes. Okay, so look at the D option. Every continuous function is differentiable. So can you say? Yeah, it is differentiable, right? Because if you have any function like this, okay, it's a constant function every time. Okay, they're differentiable. Okay, what you will say that one, they're not differentiable, then again one is anyways not there here. Okay, at two they're not differentiable, anyways two is not here. Okay, so that's the point. So yeah, a constant function is differentiable, so every continuous function is differentiable. So without doing much we got A, C and D option to be correct, right? Okay, I like this question. See you with another one.